So today we're going to talk about powers of monomials. Now, yesterday we multiplied two monomials together, and we remembered that our rule yesterday was a to the x times a to the y is equal to a to the x plus y power, right? Today we are multiplying monomials, and the rule that's associated with it is a to the x taken to the y power. Now, these problems will always have to have a parenthesis in it. That's going to be the clue to you that we are using this new rule here. There's a parenthesis with an exponent taking to it. This is when you're going to use this rule. And a to the x taken to the y power is going to be equal to a to the x y power. What does it mean when two letters are next to each other? What are they doing, Sean? You're multiplying. So you're going to multiply the powers. So when you're taking a monomial to another power, you're going to multiply the exponents. So let's go ahead and see some examples of this. So let's say we have, let's start with numbers since you're used to numbers. Let's see, Betsy, what's your favorite number? 3. All right. Juliana, what's your favorite two-digit number? 27. So we have 3 to the 27th, and we are going to take this, to the 4th power. Now, I'm going to do this the long-winded way first, and then we'll show, and that shows why this works, why this rule is appropriate. So 3 to the 27th to the 4th power, if I were to expand this, it's going to equal 3 to the 27th times 3 to the 27th times 3 to the 27th times 3 to the 27th. So if I'm multiplying monomials together, what do I do with the exponents? We add them. So let's go ahead and add them. 27 plus 27 plus 27 plus 27 is 108. But wait a second. If I were to apply my new rule right here, if I were to apply that rule, what would I have done here? Well, I would have said 3 to the 27th times 4. What is 27 times 4? 108. It's 108. And so we get the same answer. Oops, and I start writing the... Okay, I'm apparently erasing far more than I want to. Equals 3 to the 108 power. So we see how this rule works, and it makes sense. So let's try one with letters. I'm first going to take a picture. Excuse me. Thank you. I'm going to take a picture of my rule so that I can keep that and erase everything else really easily. So here we have our rule. So we can keep this and save it, not worry about it going away. Okay, so let's try some problems that include numbers, or letters rather. Let's say I have x to the 3rd taken to the 4th power. Well, we're using our second rule, right? A to the x to the y power. When you have a monomial to a power, what are you going to do with the exponents?
Well, you could do x to the 4th, x to the 3rd times x to the 3rd.
Oh, sorry. Okay, so I'm going to write what you said. You said x to the 3rd times x to the 3rd times
X to the 3rd times x to the 3rd.
And so in this case, we add the exponents, and what do we get?
That's 12.
Right. Or we could have 3 times 4. What is 3 times 4?
12.
Okay. So using this rule is fairly straightforward. It's simple. So let's try another one. So this time, let's have Allie. So we have Allie. We'll say Allie to the first, DeBolt to the 6th, and let's take this to the 8th power. Okay. Now I'm going to expand this one again, just like we have in all the others, and then we'll show how the rule gets applied so you don't have to expand all of them from here on out. So this is going to be equal to a d to the 6th times 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 a d to the 6th. How many do I have? That's 6 times a d to the 6th times a d to the 6th. Right?
Right.
Okay, I should pick a smaller exponent. So because of the commutative property, we can switch the order of our multiplication, right? So we can put all of the a's, multiply them first together. We can take all of the d's, multiply them together. So I have how many a's?
8.
I have 8. So I have a times 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 a. That's 1, 2, 3, 4, 5, 6, 7, 8. So a times a times a 8 times is going to be a to the 8th. So let's take a look at our d's. We have d to the 6th times 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 d to the 6th. I believe that's 8 of them. So in this case, what do you do with the exponents? Add them. So Henry, how many d to the what power do I have? No, not exactly, Henry. It might help if you pay attention, so playing with your compass. Yes?
48.
48. So we have d to the 48th. So I put these two together, and so I have a to the 8th, d to the 48th, and this would be my answer. Now let's go ahead and go back up to our original problem and apply our rule. This is a to what power? 1. So a to the 1st to the 8th power, what do I do with the exponents?
You multiply.
I multiply them, and I would get 1 times 8, which is?
8.
So I get a to the 8th. D to the 6th to the 8th power. D to the 6th to the 8th power. What do I do with the exponents? Okay, so I end up with d to the... Now, this is a whole lot faster than doing what we did right here, is it? Is it not? Okay, so we can start applying the rules. So I'll give you another example, and I would like you to do the problem, okay?
Yes.
Okay. All right. There we go. Okay. So this time we will have Oscar. Nurmat. We'll have Oscar to the 2nd, Nurmat to the 5th, and we'll take the whole thing to the 5th power. So go ahead, solve the problem, and stand up when you have it. Yes, I'm sorry, it is a 5. So it's O squared n to the 5th to the 5th power. That's right, you at home, or you sitting in the back of my classroom later today, you should be doing this problem too instead of just watching the video. Talking to you, Kyle. Okay. Mo. All right. So, the answer, please, Jenna. O to the 10th, N to the 25th. Okay, please have a seat. Please have a seat. All right. So my last example is going to be one that includes numbers and letters. We're going to include numbers and letters here. Going to get really wild and crazy. So we're going to have 3 Phoebe Fosters squared. And we are going to take 3 Phoebe Fosters squared to the, I'm trying to keep it a fairly small number so the actual number doesn't get too big. We'll take it to the 4th power. So now this time, I know that you know how to get the letters just fine. But I want to talk about the number, so you can sit down. I want to talk about the number. So why don't you just tell me what the variable will be right away, since you're jumping up out of your seat anyways. What's the variable going to end up being, Trevor? You don't know. Okay.
Oh, Phoebe Foster?
Yeah, those are the variables.
Okay.
So what are the variables going to end up being?
Phoebe Foster. PF.
P to the what? F to the what?
P to the first. F to the second.
No.
Oh, God.
It's okay. It's okay. Betsy?
P to the 4th and F to the 8th.
Okay, so we know that's going to be a variable. We know that up front because you're going to multiply the exponents, so you know that's going to be fine. So the one thing that we haven't talked about yet is how to deal with this number. So if I were to expand this, we'd have 3 times 3 times 3 times 3. So we're not going to multiply 3 times 4. No. We're going to multiply 3 times 3 times 3 times 3. So 3 to the 4th power is what? 3 to the 4th power is what? Here's a hint. 3 times 3 is?
9.
So that's 2 3s. We have 3 times 3, the other 2 3s. Shh. We'll try this again. We'll try this again. So if I have, so what are these 2 3s multiplied together? That's 9. The 3 times 3 is? 9 times 9 is?
81.
Oh, okay, so it's 81. So my final answer is going to be 81 P to the 4th F to the 8th. So the numbers still have to be taken to that power. The exponents are multiplied together. So we'll have one more example. Yes, Mr. Kramer, you have to do this one too.
He's talking to the microphone.
So we are going to try this one. We're going to try 2. We're going to use the best letters in the alphabet. K, C squared, F to the 5th. Those are the best letters are the best letters. I can't help that. And we're going to take this whole thing to the 6th power. So right now, go ahead and solve that problem. Go ahead and solve that problem.
Stand up or should we sit down?
I want you to stand up when you have the answer. So you've already done 2 to the 6th? Okay. I didn't think so.
I think I can figure it out.
I think you can figure it out. So stand up when you have the answer.
Oh, I got it.
Joe had a eureka moment right there.
Yeah, the bigger the O, the more he wins.
Yes, that's true. The more excited he gets.
Every time you solve the problem, it's like a huge celebration.
The light bulb goes off.
Ding.
Joe's not laughing at you. That's the way that Joe celebrates.
No, we're not laughing at you. We're appreciating you very much. No, that's just mean. All right. So here we go. Here we go. So the correct answer, Trevor B. The correct answer, Trevor B, is going to be
64, K to the 5th, or 6th, C to the 12th, and F to the 10th, or 30th. Nice.
There you go. All right. So this is how you take monomials to a power.